Hello, my name is Dylan Radulski, and this is Lab 2, Magnetic Field of a Bar Magnet, for Physics 2212 at Georgia Tech. The purpose of this lab was to calculate the magnetic field of a bar magnet and observe the effect that distance had on said magnetic field. The system was the bar magnet, and the surroundings was the earth and my phone. The magnet is set up to run east and west so the phone can measure while facing north. This eliminates the effect of the Earth's magnetic field on the results of the magnetometer on my phone. The results. The bar magnet had an experimental magnetic field of around 5.01 e to the negative 4 teslas, but the model shows the bar to have a magnetic field of 3.10534 e to the negative 5 teslas. The important physical concepts we used were Biot-Savart's law, which is the equation shown here, mu naught over 4 pi times 1 over r cubed times 3 times the magnetic dipole moment of the magnet times r hat minus the magnetic dipole moment of the magnetic bar, and the magnitude of the magnetic field of the bar is equal to kr raised to n. For the lab setup, face the magnetometer facing the north pole of the Earth, find the location of the magnetometer chip in the phone using the steps provided in the lab instructions, and measure the distances between the magnetometer and the bar magnet for on and off axis. Here's the data collected from the experiment. I found the distance in meters where my phone detected 20 microteslas, 70 microteslas, 120 microteslas, 170 microteslas, and 220 microteslas. The spreadsheet gave us the linearization equation of y equals negative 3.0504x minus 13.994. That first number is n, and the k value we got from ln of k is equal to the 13.994, so raising e to that number provides us with the k value. Here are my calculations. I used both the equations for the magnetic field of a bar, set them equal to each other, and then using the things that we had calculated on the previous page, I solved for the magnetic dipole moment of mu, which ended up equaling 4.18266 am squared. For the statements that apply, based off the last slide in this one, when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. The main place we see this are these numbers here. You can see that as the distance got further, you can see that the magnetic field got smaller, closer to zero. After we did the on-axis, we did essentially the same thing for off-axis, made all the measurements, and I ended up finding that the net magnitude of the net magnetic field to be around 5.01 times e to the negative 4 teslas. Here is the code I used. The main thing I changed was the mu mag up here, which is the 4.18266 calculated from before. This function to solve for dipole B is essentially just Biot-Savart's law. Here is this thing was to determine how far the magnet was from the observation location. That number could be whatever we wanted, and the rest of it is essentially to make arrows and do calculations to figure out the magnitude. And you can see here that the magnitude of B at the 45 degrees was 3.10534 times e to the negative 5th teslas. That is calculated in this code. Since the numbers do not match up, the sources of the error can come from inaccurate measurements, magnetic fields of things around me, improper alignment, and the magnetometer chip not found properly. What if and why? In the experiment, you oriented your setup so as to compensate for magnetic north. What if you hadn't done that and had instead laid out your meter stick at some indeterminate angle with respect to Earth's magnetic field? How would your results have changed? Earth's magnetic field would have interrupted Bx in my measurements, since it would have had an x component when measured from my phone. And imagine you had two identical magnets. What if you redid the experiment, but instead of using a single magnet, you used the two identical magnets stuck together end to end? How do you expect your measurements to differ? The magnetic dipole moment would be larger, which would also increase the magnitude of the magnetic field when measured from a distance. That is all.